This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. At higher level, the difficulty is usually increased by using the general form of a circle for one of the equations. So here we're asked to prove that the circles x squared plus y squared equals 16 and x squared plus y squared minus 6x minus 8y plus 24 equals 0 touch externally. So we want to show again that the distance between our two centers is equal to r1 plus r2, the sum of our radii. So our solution is to first find the centers and radii. So x squared plus y squared equals 16 has center 0, 0, so call that C1, and radius of square root 16, which is 4, so they'll call that R1. X squared plus y squared minus 6x minus 8y plus 24 equals 0. So you'll recall that the general form looks like x squared plus y squared plus 2gx plus 2fy plus c equals 0. And the center for an equation of that type was minus g comma minus f. So in our case we have 2g being minus 6, so divide that by 2 gives you minus 3, but it's minus g we're after, so we'll change the sign, so it's plus 3. Similarly, 2f is equal to minus 8. We want minus f, so divide by 2 and change the sign, gives you your y here for the center being 4. Our radius, the formula for our radius in the case of an equation that looks like this is given as the square root of g squared plus f squared minus c. So filling in our values for g, for f, and c are constant, which in our case is 24. We get our radius eventually, our r2, to be 1. So if we look for our values, we have our c1, our c2, our r1, and our r2. We find the distance between the two centers and the sum of the radii, and we want to see if they're the same. And once we work this down, we find out that the distance between the centers is square root 25, which is 5, which is the same as the distance, or the sum of the radii rather. So therefore our two circles touch externally. One final example is to investigate if the two circles x squared plus y squared minus 6x minus 16y plus 9 equals 0 and x squared plus y squared plus 4x minus 6y plus 12 equals 0, do these two circles touch internally this time? So what we'll be looking for is to have that the distance between our centers C1 and C2 being equal to R2 minus R1. So in this case, let's first take a look at the first equation. So this equation highlighted in red, x squared plus y squared minus 6x minus 16y plus 9 equals 0. Our center is taken as the number in front of x, divide in 2, change the sign, so we get 3. Take the number in front of y, divide it by 2, change the sign, we get 8, so our center is 3, 8, and we'll call that C1. We get our radius using the square root of g squared plus f squared minus c. Our c is 9. So when we work out this square root, we get r1 being 8. And we do the exact same thing for our second circle. X squared plus y squared plus 4x minus 6y plus 12 equals 0. Our center in this case is minus 2, 3. So we'll call that C2. And to get R2, we just use our same formula as before. Square root of g squared plus f squared minus c. So our c in this case is 12. And once we work that out, we get our radius. In this case, our R2 is going to be equal to 1. So now, given those four values, here, 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 and here, we're going to go ahead and test this up here to see, do we actually have this equality here? So we can see that when we work out our distance, we end up getting the distance between our centers to be square root of 50. And the square root of 50 is approximately 7.071. And when we work out the distance, or the difference, R2 minus R1 in this case, we get 1 minus 8, which is equal to minus 7. And the square root of 50 does not equal minus 7. So we end up having that these circles do not touch internally.